I'm back again. Today we're going to talk about naming and writing covalent compounds. If you've already done ionic compounds, most people tend to like covalent a lot better, so don't fret. Hopefully it's easier. And if you're doing covalent first, then you have something to look forward to with ionic. All right, so let's go ahead and get started. So like I said, today we're going to talk about naming and writing covalent compounds. So I want to do a quick review before we start into the logistics. A couple things to keep in mind: that an ionic compound is made up of a metal and a nonmetal. So remember that metals are on the left side of the stairs and nonmetals are on the right side of the stairs. Okay? What makes up a covalent compound? Covalent compounds are two or more nonmetals. So the nonmetals are on the right side of the stairs. So in this unit or this video, we're going to talk about just covalent. So those are our nonmetals, and all of these are on the right-hand side of the stairs. Remember, the only exception to this rule is hydrogen. Even though hydrogen's on the left side of the periodic table, it's still considered a nonmetal. So a little quick quiz you can quiz yourself. Which one of these is a covalent compound? If you said B, you are correct. We know that lithium is a metal. It's on the left side, so it's ionic right away. Okay? So there's 3 steps that you have to follow when you're naming covalent compounds. The first thing you want to do is identify if it's ionic or covalent. Get in the habit of asking yourself, is it ionic or covalent? Eventually, when they're all combined, you do need to do that. The second is you're going to use prefixes to name the compound. So in covalent, everything gets prefixes. Ionic does not get prefixes. This is where most people try to mix things up because everyone likes the prefix method, so they try to give everybody prefixes. You are not Oprah Winfrey. You cannot give everyone a prefix. Only covalent compounds get a prefix. The second, or the last step, is the second nonmetal is still going to get that IDE ending. If you already did ionic, you know that you always change that second nonmetal, or you always change the nonmetal at the end to have an IDE ending, so it's the same thing. So let's go over these prefixes. You probably use prefixes more than you thought. Bicycles is a great way to compare prefixes. Most of you have ridden a bicycle before, so bi is the prefix here, and it has 2 wheels. Now, there are other type of cycles. Unicycle, you might have seen in a circus or some people on street performers. They ride unicycles, and uni means 1, so it only has 1 wheel. And then maybe when you were younger, you rode one of these cute little things. This is a tricycle, and tri means 3, so it has 3 wheels. Okay? So let's go over these prefixes. This is something that you definitely need to know. You would have to memorize, so keep that in mind. Okay? So our prefixes that we're going to use in chemistry, the prefix for 1 is mono. If someone does a monologue, it is only 1 person, so that's a good example. Number 2 is di, so like a diagonal line. I know before bicycle was bi, we're going to use di. Di is the chemistry term. 3 is going to be tri, like a tricycle. 4 is tetra, like a tetrahedral, has 4 sides in geometry. 5 is going to be penta, like the Pentagon in Washington, D.C. has 5 sides to the building. 6 is going to be hexa, like a hexagon. 7 is going to be hepta. Now, a lot of people do get 6 and 7 confused because they look and sound the same. The easiest way to remember it is hexa has an X and 6 has an X in it. Okay? 8 is octa, like an octagon, like a stop sign. 9 is nana. And 10 is deca, like a decade or a decathlon. If you run a decathlon, it has 10 events in. All right, and finally, mono can never be used with the first compound, so keep that in mind. When we're naming prefixes, mono is never used with the first, okay? So, couple questions. Does every element always get a prefix? The answer to that is no. Remember, this is only for covalent compounds, okay? This is only for covalent compounds, and if there's only 1 in the front, mono is never used in the front, okay? So let's do some practice together. I'm going to switch out my screen so you guys can see me on the dry erase board, and I'm going to turn. Okay, so we can do some practice together. Okay, so there we go. All right, so the first one we're going to do is N2O5. Okay, so we're going to do N2O5. So we know that 2 is di, so it's going to be di. N is nitrogen, so it's di-nitrogen, and then we have O5. The prefix for 5 was penta, and O is oxygen, and oxygen becomes oxide, so it's pentaoxide. So we have our prefixes, and we change the ending to IDE. Okay, let's do the next one. CBr4. Okay, so we know that C is carbon. Now if we look, there's only one carbon. So mono is never used in the front, so it's just going to be carbon. And then we have Br4. So the prefix for 4 is tetra. Br is bromine, and bromine becomes bromide. So we changed the ending to IDE, and we gave the prefixes. So carbon, tetra is 4, and then bromine becomes bromide. Okay? All right, let's do the next one. NO2. So the next one is NO2. So we have N is nitrogen. Okay. Now there is only one, but remember mono is never used in the front, so we don't have a prefix there. 2 is di, so di is Di, and oxygen becomes oxide, so dioxide. So nitrogen dioxide. All right, perfect. Let's keep going. We have CO2. All right, CO2, we have C is carbon. There's only one carbon, and mono is never used in the front, so we can't put mono. There's 2 oxygens, so Di, and then oxide. So carbon dioxide. All right, a couple more. We have Cl2O7. There's 2 chlorine, so 2 is di. Cl is chlorine, so dichlorine. We never change the ending to the front. It's only the second one. So dichlorine. Then we have 7. The prefix for 7 is hepta. And then oxygen becomes oxide. Okay. All right, we have one more for the section. It's H2O. Oh, that's our famous water. But the proper way is not to say water, so we're going to use the fancy term. So we know that 2 is di, so it's going to be dihydrogen. Okay, so we have dihydrogen. And then we have O, which is oxygen. And how many are there? There's only one. So it's not the first element, so we can use mono this time. So mono is 1. And then oxygen becomes oxide. So dihydrogen monoxide. So now, when you want a glass of water, you can go up to someone and say, can I have a glass of dihydrogen monoxide? Yes, and my corny chemistry jokes are back. All right, now let's flip it around and go the other way. What if we need to write the formula? Okay, so let me erase, and then we can flip and do the opposite direction. So if we flip it around and do the opposite direction, we have diphosphorus pentaoxide. Okay, so di is 2. Our symbol for phosphorus is P. So phosphorus is P. Di is 2, so we write the 2 at the bottom. And then penta is 5. oxide is O, so it's P2O5. Notice for covalent, there is no crisscrossing. You're just simply writing the element with the prefix, okay? So our next one is carbon tetrahydride. Okay, so carbon is C. There's no prefix, so we assume that it's a 1. So then we have tetra, which is 4. Hydride, which is H. So it's CH4. Okay? All right, great. Let's keep moving. We have tetraiodine. We have tetraiodine non-oxide. All right, so tetra was 4. Iodine is I. Nana is 9. And oxide is O. So it's going to be I4O9. Are we catching on? Most people like covalent much better than ionic. There's no crisscrossing and nothing too crazy. All right, we have 3 more to do. We have sulfur, hexafluoride, okay. So sulfur we know is S. There's no prefix, so that's going to be no number. And remember, no number is a 1. Just because there's no number, it's not a 0. Hexa is 6, and fluoride is F. So when we write it out, it's SF6. Okay? We have 2 left to do. Let me erase. Okay, we have 2 left. Our last 2 are carbon dioxide, something you are all familiar with. We all exhale it. Okay. So carbon we know is C. There's no prefix, so there's no number. Di we know is 2. Oxide is O, so it's going to be CO2. C was carbon. Di is 2. Oxide is O. Okay. Last one is nitrogen trioxide. Nitrogen we know is N. Tri is 3, and oxide is O. So it's going to be NO3. Okay. How are we doing? Do we like covalent better than ionic? Most people do. Okay. Hopefully you guys are starting to grasp the naming and writing covalent compounds. If you have any questions, please feel free to reach out.